Opening question. Ever wondered why certain organic molecules are more stable than others, even if they have the same amount of atoms and bonds? The secret lies in a concept called hyperconjugation. Today, we delve into this fascinating world of organic chemistry to unravel the mystery. Hyperconjugation, sometimes referred to as the no-bond resonance, is a fascinating phenomenon that happens in organic molecules. It's a form of interaction that leads to the stability of certain molecules. But how does it work? Let's break it down. Imagine a molecule. It's made up of atoms, right? And these atoms are connected by bonds. Now, these bonds are not just simple links. They are dynamic, they can share, they can move. This is where the magic of hyperconjugation comes into play. Hyperconjugation involves the interaction between the electrons in a sigma bond, specifically a carbon-hydrogen bond, and an adjacent empty or partially filled atomic or molecular orbital. This interaction leads to a delocalization of sigma electrons. Simply put, the electrons are not confined to a particular place, they can move around. But why does this happen? It's all about stability. Molecules strive for a stable state. By spreading out the electron density over a larger volume, hyperconjugation disperses the charge and lowers the energy of the molecule, making it more stable. Consider an alkene, a molecule with a carbon-carbon double bond. When hyperconjugation occurs, the electrons from the CH bonds adjacent to the double bond can interact with the unfilled p orbital of the carbon atoms. This interaction spreads out the electron density, reducing the molecule's energy and making it more stable. So, the more adjacent CH bonds a molecule has, the more opportunities for hyperconjugation, and thus the more stable the molecule becomes. This is why, for instance, tertiary carbocations are more stable than secondary carbocations, which in turn are more stable than primary carbocations. Hyperconjugation is a key concept in organic chemistry that helps us understand the stability of molecules. It tells us that the stability of a molecule is not just about the number of atoms and bonds it has, but also about how the electrons within these bonds are distributed. To summarize, hyperconjugation is a phenomenon where sigma electrons are delocalized, leading to the stability of molecules. It involves the interaction between sigma electrons and adjacent atomic or molecular orbitals. The more opportunities for hyperconjugation, the more stable the molecule. So the next time you come across an organic molecule, remember it's not just the atoms and bonds that matter. It's also about the dance of electrons, the magic of hyperconjugation. Hyperconjugation, the no-bond resonance, a fascinating concept that brings a new perspective to the